Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session February-March 2024 Paper 2-2. So let's start with the first question. Question number 1, use logarithms to solve the equation. Give your answer correct to three significant figures. So we have to use a logarithm. So to solve this equation we have to use a logarithm. So taking log on both sides. Taking log on both sides. All right, so we can say log of 3 4x plus 3 equals to log of 5 2x plus 7 is the power. Okay, so applying the power rule of the log, so let me apply the natural logs over here, not log to the base 10. Okay, so we have applying the power rule as well. So 4x plus 3 is the power. So we can say ln of 3 is left equals, sorry, not 5. We have 2x plus 7 is the power. It comes before the log, which is natural log of 5. Okay, let me open the bracket. 4x times ln 3 plus 3 times ln 3 equals to 2x ln 5 plus 7 ln 5. Let me combine the x terms. 4x ln 3 minus 2x ln 5, and the constant terms on the other side, it becomes 7 ln 5 and minus 3 ln 3. Okay, now taking 2 and x common, we have 2 ln 3 minus ln 5, and here we have 7 ln 5 minus 3 ln 3. Okay, now 2x is over here and we have to divide 7 ln 5 minus 3 ln 3. This term is going to divide with 2 ln 3 and minus ln 5. Alright, and to get the value of x, we have to divide both sides by 2. So 1 by 2 into 7 ln 5 minus 3 ln 3 over 2 ln 3 minus ln 5. Let me calculate this. Okay, so 7 ln 5 minus 3 ln 3. This term, this is going to divide with 2 ln 2 minus ln 5, and you have to times this. Sorry, it's ln 3. I did the mistake, sorry. Okay, so we can say 7 ln 5 minus 3 ln 3 divide 2 ln 3 and minus ln 5 and times it by 0.5. 1 by 2 is 0.5. 6.779, and x is equals to 6.779. We have to find the answer correct to three significant figures, and three significant figures 1 2 and 3, you have to round this because it's 9. So x is equals to 6.78. This is the answer up to three significant figures. Question number 2, part A, sketch the graph of this function stating the coordinates of the point where the graph meets the x-axis, right? Okay, so that is the absolute value function. Its shape should be in the form of v, right? Okay, so let me find out the x-intercept first. So the x-intercept is when y equals to 0. So put y equals to 0. So we have 3x minus 7. This is equals to 0. So 3x is equals to 7 and x should be equals to 7 out of 3. So what is 7 by 3? In terms of decimal, we have 7 by 3 is 2.33. Okay, so this is 2.3. Let's find the y-intercept by putting the variable x is equals to 0. So for y-intercept, x should be equals to 0. So what is y? Y is absolute of negative 7. which is equals to 7. So y-intercept is 7 and x-intercept is 2.33. And if we only work with this equation, y equals to 3x minus 7, then the y-intercept is just negative 7, right? Okay, so let me sketch this x and the y-intercepts. Okay, this is in centimeters, yes. So we have 1, 2, 3, 4. And over here we have 1, 2, 3, 4, 5. 1, 2, 3. All right. Okay, so we have 2 point something. This is, let's say this is 2.33, which is 7 by 3. The x-intercept, the y-intercept would be equals to 7. If we have 2, 4, 6, then that should be equals to 7, right? These are the 2 points. We can say it's just a sketch, not the exact graph, right? And this the x-intercept, and we have some y-intercept which is equals to negative 7 for that line. So the x-intercept, let's say the y equals to negative 7 over here. So this is 2, negative 2, negative 4, negative 6, and this is negative 7. Negative 7, negative 8 is over here, negative 7 is over here. So connecting the two lines, so this, so remove this one, so that should be the shape of the graph, because it is absolute value function, it is more above the x-axis. Yes. Now for part B, hence find the set of values of the constant k for which this equation y is k x minus 4 has exactly 2 real roots. Okay, it is just a 2 marks question, so we are not solving it algebraically, hence means we have to use the A part for solving the B. Okay, it has 2 real roots. What does 2 real roots means? 2 real root means 2 points of intersection. 2 points of intersection. All right. So if I suppose this with the negative, right? Okay. Because as we know, this straight line is y equals to 3x minus 7. This line shows with y equals to 3x minus 7, right? So let me, but we are working with this absolute, the whole absolute, right? So let's say, take the negative 3x minus 7. This is equals to k into x minus 4, right? So let us suppose y is equals to minus 3x minus 7. So y would be equals to negative of 3x plus 7. So what is the slope of this line? So we got the slope. So from here the slope is m, that is equals to negative 3. So the slope of this line is negative 3, right? Okay, so on the other hand, we can say let y is equals to k into x minus 4, right? So let us suppose k, the slope is k, which is negative 3. So y equals to minus 3 into x minus 4. Y is equals to minus 3x, and we have plus 4, right? Now let's say x is equals, when x is equals to 0, y is equals to 4, and when y is equals to 0, what is my x? When y is 0, the x would be equals to 4 is shifting on the other side. Sorry, this is 12, positive 12, yes. Okay, when y is equals to 0, we have negative 12 divided by 3, which is 3 times 4 is 12, yes. So when x is 0, y value is 12. I messed up, sorry. And when y is 0, x is negative 12 by 3. 3 times 4 is 12, that is 4. So we have the point x is 4 and the y is 12. So where the x is 4, it's 1, 2, 3, and 4. X is 4 over here, and y value is 12. This is 2, 4, 6, 8, 10. And let's say that 12 is at the top. Let me extend this. And we have some 12. This is the 12. This is 12 and this is 4, right? So if I draw the line, as you can see, it has only one point of intersection. Point of intersection. when the slope is -3, it has only one point of intersection, right? So we have to find when it has exactly two real roots, it has 2 points of intersection. So if I draw this line, it has 2 points of intersection, 2 points of intersection, 2 points of intersection, right? So let me check the k value. Let's say -2, right? Let k is equals to -2. So we have y is equals to -2 into x minus 4. So when x is equals to 0, what is my y? Y would be equals to -2 into -4, that is equals to 8. And when my y equals to 0, what is my x? When y is equals to 0, what is my x? X is equals to 4. Yes. Okay, so we have a point x is 4 and y is 8, right? X is 4 and the y is 8 over here. 8 is over here, let's say. So let me draw this line, 4 and 8, connecting the 4 and 8. So now you can see it has 2 points of intersection. This is a point of intersection and this is a point of intersection. Now when the slope is -2, sorry, it's -2, it has 2 points of intersection. Let me check. Let k is equals to -1. So y would be equals to negative into x minus 4, right? Find out the x-intercept. X is equals to 0. We have y equals to 4. And when y is equals to 0, what is my x? X should be equals to 4. So x is 4 and y is 4. We have 4 over here, right? So x value is 4 and the y value is 4. Let me draw this line. So again, you guys can see it has 2 points of intersection, this curve and this. These are the 2 points of intersection. So we have to find, with the help of the above part, hence means using the above part, find the set of values of the constant k for which this equation equals to this one has exactly two real roots. So the absolute function, this absolute function equals to some k into x minus 4 has exactly two roots. So k over here is basically a slope, right? So we can see when the slope is between -3 and 0, we have two solutions, right? When the slope is -3, it has one solution. When the slope is 2, it has two. -2, it has two solution. -1, it has two solution. Let's say when the slope is 0. When the slope is 0, it is just a straight line, right? So we can say that set of values of k when equation has two real roots are when the k values between -3 and 0. So when the slope is between -3 and 0, at -3 it has one solution and at 0 it has one solution, but between -3 and 0 we will get two solutions for this absolute value function. The straight line touched the absolute value, cut the absolute value function at 2 points. I hope this makes sense now. Question number 3, the polynomial p of x is defined by, this is the polynomial where a is a constant. It is given that 2x minus 1 is a factor of p of x. If it is a factor, then 2x minus 1 equals to 0. So x would be equals to 1 by 2. If it is a factor, it means p of 1 by 2 should be equals to 0, right? So let me solve what is p of 1 by 2 and put it equals to 0. So this is 6 and we have 1 by 2 its whole cube, we have plus a, we have 1 by 2 its whole square, plus 3 into 1 by 2 minus 10, put it equals to 0, right? Okay, now for part A, find the value of a and hence factorize p of x completely. All right, so one information we have given that 2x minus 1 is a factor. When it is a factor, it means p of that factor should be equals to 0, right? Let me simplify. This is 6. 1 cube is 1, 2 cube would be 8, plus a, 1 square is 1, 2 square would be 4, and plus 3 by 2, negative 10 equals to 0. Let me solve for a from here. This is 6 over 8 plus a by 4 plus 3 by 2 minus 10 equals to 0. Okay, so that would be a by 4 is over here. Shift the rest of the terms on the other side. It becomes positive 10, negative 3 by 2 and negative 6 by 8. This becomes negative, this becomes negative, and this becomes positive. Let me simplify. So from From 10 we have to subtract 3 by 2 and subtract 6 by 8. This is 31 by 4. So a by 4, this is equals to 31 by 4. So we can cancel 4 with the 4. So the a value is 31. We got the value of a. The first part, first thing first, we have to find the value of a. Now hence factorize p of x completely. Now factorizing p of x completely, we can say, okay, 3a. We have p of x now is equals to 6x cube. A value is 31 plus 31x square. I'm just writing this down. Plus 3x and minus 10. Okay, so one factor we have given, which is 1 by 2. Let me apply the method of synthetic division over here. Right. So write down the factors, coefficients of x cube, x square, x, and the constant. Okay, and one thing we have given 1 by 2 is the factor, so bring the first term as it is down. 1 by 2 times by 6. 1 by 2 times by 6 is 3. Let's add them up. 3 plus 31, this is 34. 34 times 1 by 2, this is 17, and 17 plus 3 is 20. And 20 times 1 by 2, that is 10, and 10 minus 10 is 0. Now these are the reduced form. In synthetic division we have to reduce the equation from cubic to quadratic. Alright, now let me write down p of x. We have the factor x minus 1 by 2 is the factor, and the rest of the square term, quadratic equation would be 6 is the coefficient of x square, 34 is the coefficient of x, and 20 is the constant term. All right, now this polynomial p of x, this becomes 2x minus 1 divided by 2, and we have let me take 2 common as well from this. 2 times 3 would be 6, and 34 divided by 2 is 17, plus 17x and 10. So this 2 and this 2 is cancel out. We have p of x is equals to 2x minus 1 into 3x square plus 17x plus 10. Okay, 3 times 10 is 30. We have to find the factors of 30, where that sum should be equals to 17. 3 times 10 is 30. But when we add 3 and 10, that would be 13, and when we subtract, we have 7, not 17. Okay, 2 times of 15 is 30, and 2 plus 15 would be 17. Yes. So p of x is equals to 2x minus 1. I'm just factorizing this, right? 3x square. 17 we can break as 2x and 15x plus 10. So now the polynomial in the factored form, we have to write this down. This would be 2x minus 1. Okay, x is common. 3x plus 2 is the factor. Okay, and let's take 5 common. 5 times 3 is 15, and 5 times 2 is 10. So the factors inside the brackets are same. So p of x is equals to 2x minus 1, 3x plus 2, and x plus 5. So these are the 3 linear factors. All right, now moving to the second part of question number 3. Solve the equation p of cosecant theta would be equals to 0 when theta is between negative 90 degree to positive 90 degree, right? So what is p of x? P of x, we have done the 3 factors. Let me write this down, which is 2x minus 1 and 3x plus 2 and x plus 5. We have to put this equals to 0. Let me solve first. P of x equals to 0, and let x would be equals to, okay, so let x is equals to cosecant theta. All right, so if I put this equals to 0, it means 2x minus 1 equals to 0, 3x plus 2 would be equals to 0, and x plus 5 would be equals to 0, right? So x is 1 by 2 from here, x is minus 2 by 3 from here, and x is negative 5 from here. Let's put it back. X is cosecant of theta, right? Let me solve this over here. X would be cosecant of theta, and we have the 3 factors. Okay, so this is the B part. So we can say cosecant theta is 1 by 2. Cosecant theta is minus 2 by 3. And cosecant theta is negative 5. Let me solve for theta. Cosecant is basically a reciprocal of sine. Cosecant is 1 over sine. So 1 over sine theta is 1 by 2. And 1 over sine theta is minus 2 by 3. And 1 over sine theta is negative 5. Let me do the reciprocal. So sine theta is equals to 2 sine theta, reciprocating both sides. 1 over sine, sine over 1, 2, 1 by 2, 2 by 1. This is minus 3 by 2. And reciprocating both sides here, sine theta is minus 5 becomes minus 1 over 5. Let me solve for theta. Theta is sine inverse of 2. Here theta is sine inverse of negative 3 by 2. Here theta is sine inverse of negative 1 by 5. Alright. Let me solve this. It must be in degrees. So my calculator is in degrees. Sine inverse of 2 does not exist. Sine inverse negative 3 by 2 does not exist. Sine inverse of negative 1 by 5 is minus 11.5. So theta is only negative 11.5. That is the only solution in terms of degrees, and this solution belongs to the given range we have from minus 90 to 90 degrees. Question number 4. The diagram shows the curve with equation y equals to this. The shaded region is bounded by the curve and the straight line. X equals to 0, x is equals to 6, and y equals to 0. Number A, use the trapezium rule with the 3 intervals. 3 intervals mean n should be equals to 3. To find an approximation to the area of the shaded region, give your answer correct to 3 significant figures. So what is the trapezium rule? The trapezium rule, we can find out the area. It has a formula which is half times h into y naught plus yn plus 2 into y1 plus y2 plus up to so on yn minus 1. And the middle terms are times by 2, and the first and the last term are just added. And where what is h? Where h is b minus a over n. Okay, so what is a? A is this and b is this. A is 0, b is 6. So we can say a is 0, b is 6. We can say 6 minus 0 over 3 number of iterations, which are 6 over 3, and 3 times 2 would be 6. So the h value is 2, right? And what is y naught and the rest of the terms? Let me write this down as well. Where y naught is f of a, which is f of the function. F of a value is 0. F of 0 we have to find root 1 plus e. 0.5 times 0 is just 0. This is square root of 1 plus e power 0 is 1. So this is square root of 2. And y1, what is y1? Which is f of a plus h. And this is f of a is 0 and h is 2. This is basically f of 2 we have to solve. So let me solve for f of 2, which is root 1 plus e, 0.5 into 2. Okay. 0.5 times by 2 is 1. This is root 1 plus e power 1. Wait, what is y2? Y2 is f of a plus 2h. A value is 0. F of 0 plus 2 into h is 2. Basically, we have to find f of 4. So this is root 1 plus e, 0.5 into 4. 0.5 times by 4 is e power 2. So root 1 plus e power 2. We have to use 3 intervals, 1, 2 and 3. No need to find the rest. No, sorry, 3 intervals we have to find till y3. Y3 would be f of a plus 3h. F of a is 0, 3 and h value is 2. So here we have to find f of 6. Alright. So this is root 1 plus e, 0.5 into 6. 0.5 times by 6 is 3, e cube. Root 1 plus e cube. Okay, let me plug all the things into the formula. Now let me plug all the values into the formula of area trapezium rule, which is half. We have done the h is 2 times by 2 into y naught. Y naught is root 2 and y1 is this. Okay, so 2 into root 1 plus e is the y1. Y2 is root 1 plus e square and y3 is 1 plus e cube. We can multiply the middle terms with 2 and the first and the last term stays as it is. So this 2 and this 2 is cancel out. Let me just simplify this. Okay, solve this bracket. Root 1 plus e power 1 plus root 1 plus e power 2 is this, and times it by 2. This term is simplified. Add root 1 plus e to the power of 3 and add root 2. This is 15.655. 15.655. We have to find the answer correct to 3 significant figures, 1, 2 and 3. So this is 15.7. Now for part B, the shaded region is rotated completely about x-axis. Okay, this is a shaded region. This is rotated completely about x-axis from 0 to 6. Alright. Find the exact volume of the solid produced. So the formula for the volume is pi integration from a to b y square dx, because it is about x-axis, right? So the volume, what are a and b? A and b is 0 to 6. We have pi outside, and y square is 1 plus e power 0.5 x dx. Because it is a square root, when we are taking square it cancel out, right? Let me integrate this. So volume is equals to pi is outside, integration of 1 is x, e to the power 0.5x divides 0.5 and from 0 to 6. So now volume is equals to pi x plus 1 over 0.5 is, I guess, 2 e power 0.5x 0 to 6. Let me simplify this. Volume is pi, the upper limit is 6 plus e 2e 0.5 into 6 minus pi, the lower limit is 0 plus 2 e to the power 0. So this volume is pi 6 plus 2 e to the power 0.5 times 6 is 3 e cube minus pi, this is 0 plus e power 0 is 1, 0 plus 2 is 2. Okay, so this volume is pi 6 plus 2 e cube minus pi into 2. Let me take pi common. Volume is pi is common. We have 6 plus 2e cube minus 2. 6 minus 2 would be 4. So pi is equals to 4 plus 2e cube. Let me simplify. This would be the exact volume, or you can just simplify. We have or keep it the answer in terms of e and pi. That is also okay, which is 4 pi plus 2 pi e cube. Yes, or you can find it exactly by doing a calculation. Both are correct. Question number 5. The diagram shows the part of the curve with the equation this. At point P, the gradient of the curve is 6. At point P, the gradient of the curve, it means the derivative of the curve dy over dx equals to 6. The derivative of this curve is equals to 6. Number A, show that the x-coordinate of P satisfies the equation. Okay, so first thing first, let me find out the gradient and put it equals to 6. Dy over dx. We have y. Let me apply the quotient rule. Denominator function, its whole square. The denominator function, the derivative of numerator function is 3x square minus x cube. Numerator function, derivative of denominator is just 1. Okay, now we can say that 3x square times x would be x cube plus 3 times 2 would be 6x square minus x cube divides x plus 2 whole square, put it equals to 6, and we have to solve for x. So this is 2x cube plus 6x square, and this is 6 into x square plus 4 plus 2x, 4x. X square, 2 square would be 4, and 2 times 2 times 4, 2 times 2 times x would be 4x, yes. So 2x cube plus 6x square, this is 6x square plus 4 times 6 would be 24 plus 24x. This 6x square and this x square is cancelled out. When we shift this on the other side, it becomes negative. So positive negative would be 0. And we are left with 22x cube minus 24x and plus 24. This is equals to 0. Dividing throughout the equation by 2. Dividing this side by 2 and this side by 2. 0 by 2 is just 0. So x cube minus 12x plus 12. This is equals to 0. This becomes negative and this becomes negative as well. So both are negative. We have to find this. This would be our solution. So 12x and 12 shifting on the other side. From here, x cube would be equals to 12x plus 12. And what is x? X should be equals to cube root of it. Cube root of 12x plus 12. Now it is proved that x coordinate of P satisfies this equation. Now for part B, show by calculation that the x coordinate of P lies between 3.8 and 4.0. So what is x coordinate of P? The x coordinate of P is x equals to cube root of 12x and plus 12. Alright. And we have x minus cube root of 12x plus 12. Put this equals to 0, and we have to let this is f of x. We can say f of x is equals to x minus cube root of 12x plus 12. This is my f of x, right? Okay. Now let me find what is f of 3.8. f of 3.8. This is 3.8 minus cube root of 12 into 3.8 plus 12 and the root. Okay, let me simplify. We have 12 into 3.8 plus 12 cube root of answer and 3.8 subtract answer minus 0.062. This is less than 0, right? Now what is f of 4.0? f of 4.0 is 4.0 minus cube root 12 into 4.0 plus 12. Okay, 12 into 4.0 times plus 12 and cube root of answer and 4 subtract answer. This is equals to 0.085. This is more than 0, right? So as you can see, the sign change occur over here. Whenever we have a sign change between the two values of x, it means there is a root lies between those two values, right? Now we can say, hence f of 3.8 is less than 0 and f of 4.0 is greater than 0. There is a sign change. And whenever we have a sign change, we can say, hence the x coordinate of P lies between 3.8 and 4.0. Whenever we have a sign change, the root lies between the 2 points. Yes. Now for part C, use an iterative formula based on the equation in part A to find the x coordinate of P correct to 3 significant figures. Show the result of each iteration to 5 significant figures. The result of each iteration should be 5 significant figure and the x coordinate should be 3 significant figures. Okay, let's make an iterative formula. The x coordinate of P from part A we got is x is equals to cube root of 12x plus 12. To make an iterative formula, the subscript is n plus 1 and this would be n, right? Okay, now as we know that the x coordinate of P lies between 3.8 and 4.0, so we have to pick the initial guess would be between 3.8 and 4.0. Let me take 3.9. Let x naught is 3.9. Let me solve for x1. What is x1? When n is equals to 0, n is equals to 0, right? So this is cube root of 12 into x naught, which is 3.9 plus 12. And we have to find the x coordinate of P up to 3, but each iteration should be up to 5 significant figures. Let me simplify. 12 times 3.9. Okay. Now let me find the cube root of 12 times 3.9 plus 12 up to 5 significant figures. 3.8886 if I round this number. Okay, now x2, this is cube root of 12 into this number, 3.8886 plus 12. So in this one, 8886, we have 3.8856. Okay, x3 is cube root of 12 into 3.8856 plus 12. 3.88, sorry, 5 and 6. This would be equals to 3.884 and 7 replaces to 8. Yes. Okay. Now we can easily guess the x coordinate of P up to 3 significant figure. This is approximately 3.88, 3.88, 3.88, 3.88. Yes. And it must lies between 3.8 and 4.0. Question number 6, the diagram shows the curve with the parametric equation. We have x in terms of t and y in terms of t. For t is between 0 to 25, the curve crossed the x-axis at point A and B. This curve crossed the x-axis at A and B and has a minimum point M. Part A show that dy over dx should be equals to this. Okay, so here we apply the chain rule because x is in terms of t and y is also in terms of t. So we can say first let solve dx over dt. We have x over t, so we can say d over dt with respect to that this x function 1 plus square root of t. The derivative of 1 is 0. The derivative of square root of t is 1 by 2. The power rule we are applying, the power is 1 by 2, the base is t, power is 1 by 2 minus base, and the derivative of dt over t would be equals to 1. Okay, so we can say dx over dt, this is equals to 1 over 2 square root of t, because the 1 by 2 minus 1 is negative 1 by 2, negative 1 by 2 shifting to the denominator, so t power is positive 1 by 2, so it becomes square root of t. Okay, now the next one is, we can say dy over dt. Let me solve this. Okay, it's a product rule. We have to apply the product rule. So the first function is ln t plus 2, it's as it is. The derivative of second function d over dt of ln t minus 3 plus the second function ln t minus 3 is as it is. The derivative of first function d over dt of ln t plus 2. Let me simplify this derivative. Okay, so this is ln of t plus 2, and this is going to be 1 over t, and constant derivative is 0, plus ln t minus 3, and this is again 1 over t. Ln t derivative is 1 over t and 2 derivative is a constant which is 0. Okay, so let me take ln t common, 1 over t is common in both. We have ln t plus 2 plus ln t minus 3. Okay, again 1 over t is common. We have 2 times of ln t and negative of 1. This would be the derivative dy over dt. Let me apply the chain rule. Dy over dx, this is dy over dt times dt over dx. We have dy over dt, y over t. dt over dx is basically the reciprocal of this. Let me show you. dt over dx, the reciprocal of this side and the reciprocal of this side would be 2 root t. Let me plug this. Let me put all the values. Dy over dx, this is 1 over t into 2 ln t minus 1 times 2 root t. Okay, we have to express the answer in terms of this. Dy over dt should be equals to this. Okay, all right, so this is 2 ln t multiplied with 2 root t, so 2 times 2 would be 4 root t over t and ln t. This 1 over t times minus 1 is minus 1 over t and times by this, so minus 2 root t over t. Okay, so 4 ln t and minus 2, it means we have to take root t common. Okay, so root t is common and divided by t is common. This is 4 ln of t and minus 2. Okay, so we can just simplify. So here the t power is 1 by 2 and here the t power is 1. So 4 ln t minus 2, we have to shift this into the denominator. So 1 over t power 1 minus 1 by 2, 4 ln of t, because in the denominator we need t power 1 by 2, and 1 minus 1 by 2 is 1 minus 1 by 2. This is 1 by 2, so we have 1 over root t into 4 ln of t minus 2. So this is exactly the same. We have showed dy over dt, dy over dx is this. Now for part B, find the exact gradient of the curve at B. Okay, so this is the gradient of the curve. From part A, we have done the gradient of the curve. We have to find the gradient, exact value of the gradient of the curve at point B. This is the point B. As you can see at point B, the y is equals to 0. The curve crossed the x-axis. It means y should be equals to 0 at point A and at point B. The y is equals to 0. Let me put y equals to 0 and solve for point B. Point B, we have to put y equals to 0. So it means ln of t plus 2 and ln of t minus 3. This should be equals to 0. It means ln of t plus 2 is equals to 0, and we can say ln of t minus 3 is equals to 0. Here we have ln of t minus equals to minus 2 and ln of t equals to 3. Okay, what is t? T should be equals to e power minus 2, and here t should be equals to e power 3. So if I simplify, what is e power minus 2? This is 0.13. 0.135, and e power 3 is, this is 20.09. Okay, so we have, this would be the y coordinate, x coordinate of A, and this would be the x coordinate of B. Okay, so we have two t values. As you can see, for A and B, the y should be equals to 0. There is some x. We have done with the t. Let me plug the t separately into this x equation to get the value of x, and we can see which one we have to use for B. Okay, so x we have is 1 plus root of t, right? Let me plug this. Okay, so 1 plus root e power minus 2 or 1 plus root e power 3. Okay, 1 plus root e minus 2. This is 1.368. and 1 plus root e3. This is 5.48. Okay, it means this x coordinate, the x coordinate of A, the y coordinate is obviously 0 because they are lying on the x-axis. This A is 1.368 and this B is 5.482. all right, so it means which t value we have to substitute into the derivative. This t value we have to substitute t equals to e cube, because from this value we got the b. Okay, so we have to find the exact value of the gradient dy over dx at t is equals to e cube. Okay, dy by dx is 4 ln e cube minus 2 over root e cube. Let me simplify. 4 ln e cube, okay, minus 2 and divided by, sorry, square root of e cube. This is 2.2. This is equals to 2.2313. Okay, or you can find the exact value only. So ln e, this would be just 3, so 4 times of 3 and minus 2, and this is e to the power 3 and whole power is 1 by 2, and this is 12 minus 2 over e power is 3 by 2, and this would be 10 e to the power minus 3 by 2. This or this, both are the same, the exact values. Moving to part C, find the exact coordinate of M. Okay, so we need to find the exact coordinate of M, since M is the minimum point, and we know that whenever we have a maximum point or the minimum point, these are basically the turning points of the curve. We have to put the derivative equals to 0 and solve the coordinates. We have the derivative dy over dx, which is equals to 4 ln t minus 2 over root t. We have to put this equals to 0. Okay, so cross multiplication, 4 ln of t minus 2 is equals to 0, then 4 ln t equals to 2, and ln of t is equals to 2 by 4, which is equals to 1 by 2. So from here we can say ln of t is equals to 1 by 2, and what is t? T would be equals to e power 1 by 2. Let me solve for the exact coordinates of m, means the x and the y. So let me substitute the t value into x and y. So for x we need the t, 1 plus root t. So the x coordinate is 1 plus square root of t. T is this. So this is 1 plus e power 1 by 2, and the whole power is also 1 by 2. This is 1 plus e to the power of 1 by 4. This is x coordinate, and the y coordinate we have is, we can use ln of t plus 2, ln of t minus 3. So ln of t is 1 by 2. So 1 by 2 plus 2 and 1 by 2 minus 3. Let me use this. Okay, 1 by 2 plus 2 is 5 by 2. And 1 by 2 minus 3 is minus 5 by 2. 5 times 5 is 25, 2 times 2 would be 4. So these are the exact coordinates of m. Let me write this down. The exact coordinates of m are, the x coordinate is minus 25 over 4, and the y coordinate is 1 plus e to the power 1 by 4. Question number 7, part A. Prove that left hand side equals to right hand side where a and b are constants. Let me start from my left hand side and prove that it is equals to right hand side. Okay, sine 2 theta is 2 sine theta cos theta into a. Cot is cos theta over sine theta plus b, and tan is sine theta over cos theta, right? So 2 sine theta cos theta, and inside the bracket we can make the same denominators. We have sine and cos, we have two denominators, so we can multiply this by the opposite denominator, a cos square theta plus b, and this opposite denominator would be sine square theta over sine theta and cos theta. Okay, now we can cancel sine theta with sine, cos theta with cos. We are left with 2a cos square theta plus 2b sine square theta. Okay, now as you can see, our right hand side is in terms of cos 2 theta. So we have three identities of cos double angle. Let me write down the identities. We have cos 2 theta is, the first identity is cos square theta minus sine square theta. So this identity we cannot use over here. We have 2 cos square theta, 2 sine square theta, but we have a and b as well, so we cannot use this. And the next is 2 cos square theta minus 1, and the next is 1 minus 2 sine square theta. So we can use, we have sine squared, right, and we have cos square, we can use this one. Okay, so for this identity, 2 cos square theta minus 1. So if I multiply both, this is a multiplying by a. Okay, so it means we have to add and subtract a over here, add and subtract b over here. Okay, let's do this. 2a cos square theta minus a plus a. Okay, plus b minus b plus 2b sine square theta, right? So if I can take a common from here, so 2 cos square theta minus 1. So 2 cos square theta minus 1, this is cos 2 theta, right? This plus a stays the same. Let's do this. Okay, so we have, if I can do b over here, and we can take a negative b as well. So plus b is as it is, take minus b common. We have 1 minus 2 sine square theta over here. 1 minus 2 sine square theta, right? So we can say this is a, this is cos 2 theta, plus a plus b minus b into cos 2 theta, right? So we can say a plus b is outside. We have a minus b and cos 2 theta. This a plus b is over here, a minus b, and the common is cos 2 theta, and this is my right hand side. It is proved. All right. Now for part B, find the exact value of this integral. Okay. Sine 2 theta, 5 cot theta, 3 tan theta. If I compare it with this one, sine 2 theta, a value is 5 and b value is 3. Okay, as we know that, let me write down a equals to 5 and b equals to 3, and this term would be equals to this. Okay, so we can say sine 2 theta 5 cot theta plus 3 tan theta, this would be equals to a plus b 5 plus 3 plus bracket a minus b cos 2 theta. Now we have 8 plus 2 cos 2 theta. Let me integrate with respect to d theta, and the limits are from pi by 12 to pi by 6. Alright, now the integration of 8 is theta from pi by 12 to pi by 6. Okay, so 2 is outside. The integration of cos 2 theta is sine 2 theta, and the derivative of 2 theta is 2, and the limits are from pi by 12 to pi by 6. We can cancel 2 with 2. So we have 8 theta plus sine 2 theta. Let me apply the limits now. Pi by 12 to pi by 6. The upper limit is pi by 6. 8 into pi by 6 plus sine 2 into pi by 6. This is the upper limit, minus the lower limit is 8 into pi by 12 minus sine 2 into pi by 12. Alright, now let me simplify this. Let me solve the pi terms. 8 by 6 would be 4 by 3 pi, and 2 by 6 is pi by 3. So in radians, let me convert it into radians. Sine pi by 3, this is root 3 over 2 minus, what is 8 pi by 12, 2 by 3 pi, and minus 2 by 12 is pi by 6. So sine pi over 6 is 1 by 2. Simplify this further. We have 4 by 3 and minus 2 by 3 pi. 4 by 3 minus 2 by 3. This is 2 by 3 pi, and the rest of the terms, these two are the rest of the terms. We can write this down, root 3 over 2 minus 1 by 2. Now for part C, solve the equation. This equation should be equals to 11 for alpha is between negative pi to positive pi. So this would be equals to, as we know, this whole term sine to theta, this term equals to this much, right? Now what is a and what is b? So a and b are the coefficient of cot theta and tan theta. So a is 2 and b is 7 over here. A equals to 2 and b equals to 7. And what is my theta? We have 2 theta. We have 2 theta is basically 2 alpha over 3. So we can cancel this out, and we got that theta is 1 by 2, 1 by 3 alpha. Replace this. So we can say this whole term would be equals to a plus b plus a minus b cos 2 theta, and that is equals to 11. Let me simplify now. So a and b are 2 plus 7 plus 2 minus 7 cos 2 theta. This is 11. 7, 8, 9 minus 5 cos 2 alpha over 3 equals to 11. All right, minus 5 cos 2 alpha over 3 equals to 11, take away 9, that is 2. So minus 5 cos 2 alpha over 3 would be equals to 2. So cos 2 alpha over 3 would be negative 2 by 5. Okay, so cos of 2 alpha over 3 is minus 2 by 5. So cos is negative in the second and third quadrant. So basically we have to find this angle. Let me show you. Cos is negative in this second quadrant and in the third quadrant. Alright. So this angle we have to find, and this angle we have to find. Alright. So we can say 2 alpha over 3, this should be equals to cos inverse of 2 by 5. Okay, and let me do in radians. Cos inverse 2 by 5, that is 1.15927, that is equals to 1.159279. Okay, and for second quadrant, because cos is negative in second and third quadrant, we have okay, it's quadrant. Okay, so we can say this quadrant is, we can do pi minus that angle. We can say pi minus, okay, pi minus answer, sorry, pi minus 1.159279, that is 1.9823. Okay, so 2 pi by 3, this is 1.9823, and minus 1.9823. This is for the positive side and this is for the negative side. All right, now let me solve for alpha. Alpha would be equals to 3 by 2 times of 1.9823, and from here alpha is equals to 3 by 2 into minus 1.9823. So times by 3 divided by 2, which is 2.97, up to 3 significant figures. So here alpha is 2.97 and the other value of alpha is negative 2.97, and these two values belongs to the range, which is minus pi is less than alpha is less than pi. Pi is basically 3.14, so they belongs to the pi between negative 3.14 to positive 3.14. So that was the last question of our paper. If you have any queries, please drop in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.